This lecture is going to be over the different types of composite fibers. Some of our objectives are to identify the different weaves and then also the different types of materials used to make up the fabrics that we use. Some of our forms of reinforcement, the most basic way that fibers come is what's considered a tow or a roving. And this is basically just a material that is sort of just a string of material that hasn't been wound at all. It's just straight fibers of material. If you look in the picture, you can see the end kind of frays real easily. So it's not like a piece of thread where they twist it and they wind it together so it doesn't unravel. It's just straight fibers that are in a little cylinder form, kind of, that make like a string. So when you're talking about a tow, it's basically an untwisted bundle of continuous filaments, usually designated by the number followed by K. So, and a K is 1,000. So if something has 12 K, the tow has 12,000 filaments in each fiber packet. So the bigger the number is, the thicker the thread is, basically. So the stronger it is, the larger the K value is to the tow that they're going to make the fabric out of. So some fabric can be made out of a thinner tow and be a lighter weight, and other fabrics can be made out of thicker tow and be a heavier weight. So when you're purchasing carbon fiber, you'll find some manufacturers have very heavyweight carbon fiber braid or lightweight, and that's a result of the different types of tow, or the different Ks that the K value of the tow that they're using to produce the braid or the sheet material. So they can get different thicknesses in the tow. There's isotropic and anisotropic. Isotropic means that it has strength in all directions. So if I take a piece of plywood and I bend it one way and then I bend it at 90 degrees to that piece of plywood is going to be just as strong in each direction. So it's isotropic, and it's equally strong in all directions. If something's anisotropic, it's not as strong one way as it is the other way. So those, the tow, if you looked at that, it would be strong in its lengthways, but it wouldn't be strong across its side because the fibers would just fall apart when you tried to pull on them. So that would be like an example of an anisotropic material. So isotropic means it's strong in all directions the same. It's kind of homogeneous in its strength. So there's different types of ways we can buy reinforcements. There's different types of sheeting, and it comes in tube forms, and there's directional types of materials. And the first one we're going to talk about is a veil mat. And we typically don't use these in prosthetics a lot. They're more used in other industries where they do composite layups and things. But there's no reason why you couldn't use them in prosthetics if you wanted to. It's a real thin, almost like tissue paper type of a mat material that's strong in all directions, and it's just kind of random in the way that the fibers are laid out. It's just like a real light tissue paper, and they can use that to kind of pad between the different layers of fibers to keep the weave and things like that from showing through. So it's a very thin veil mat. We don't use them very much in O&P. The next one is chopped strand fiberglass. This is somewhat like felt that's made out of fiberglass. So it's just kind of random orientation. They kind of go all over the place, and so it's strong in all directions. And it comes in different thicknesses and wide widths or small widths. And it's just basically for all-around reinforcement. It's the cheapest type of fiberglass to buy, so it's just kind of a cheap fiberglass, and so as a result, it's quite readily available and used quite often. Again, we don't use this much in prosthetics because usually in prosthetics we're going for directional strength and to make something as strong as we possibly can. The next one is a woven fabric, and we do use these quite often in prosthetics. These are typically used for sheets, and so you purchase them in sheets, so you may get like 3 by 5 sheet of woven fabric, And there's different types of weaves that you can purchase when you buy your sheet materials. Some of them are directional in strength, so they may not be as strong one way as the other. If you want to make something strong in all directions, you may have to overlap and change the orientation of your fiber. So instead of running two sheets in the exact same direction, you may have to offset them by 45 degrees so they run a little bit different direction, so you get strength in all the directions that you want. But these are woven fabrics, just like a shirt has woven fabrics. This is the same thing, just woven out of carbon or Kevlar or fiberglass. This is an example of a plain weave, and the plain weave are probably most common ones out there. They're easy to work with. They don't tend to ravel, so as you cut them, they don't ravel too much. They ravel a little bit, but not as bad as some of the other ones do. They have usually a 90-degree weave to them, so they're 90 degrees to each other. One of the things about it is the weave, like if you follow this one piece of rowing here, or string, it's going to go under a fiber, over a fiber, under a fiber, over a fiber, and every time it has to go over and under a fiber, it has to turn back on itself and kind of snake around. And so that angle weakens the fiber. The fiber is going to be strongest if you just pulled it taut and it was straight. But if the fiber has to go around things and then we pull on it, it tends to want to break and cause trouble. So it's not the strongest weave that's out there because of that. It also doesn't conform well around odd shapes. So if you have to get something that's going to conform and lay nicely over an odd shape, it's probably not the best weave for that either. It's going to be kind of hard to get it to lay into, complex curves and things. But that's a plain weave. And then we have a twill weave. The difference in a twill weave is instead of going over, under, it goes under one, over two, under two, over two, under two, over two. So the weave is a little bit straighter, so it doesn't, the weave doesn't have to go in and out, in and out, in and out quite as much. And that makes the fibers lay flatter and should theoretically make it stronger. This also tends to lay into odd contours and complex shapes a little bit better and easier. But when you cut this, it does tend to run a little bit more, and the fibers want to kind of come out of their right place, so it's a little bit more difficult to work with in that respect. Then for this one is our carbon braid. This is probably what we use the most of in the orthotic and prosthetic industry. It's a tubular stockinette braid that comes in different widths, just like stockinette does or socks. So you can get this in like 2-inch, 4-inch, 6-inch widths, 10-inch, 12-inch, 14-inch widths. Typically the fibers are set at 45 degrees, but depending on how much you stretch it will determine that degree orientation. So it may change from a very from one angle to another angle depending on how much you stretch the fabric as you put it over top of the positive model. And again, this is the most common material that we use. Then we have tapes, and tapes are just exactly what they sound like. They're rolls of carbon fiber in a tape form. They can be unidirectional, so you only have fibers running in one direction, or you can have bidirectional, where it runs at a 45-degree angle, like the carbon braid does, but just in a flat sheet. And you can get these with different types of materials. They might be carbon fiber and Kevlar and things like that mixed together, just depending on what you want to do it. And then the bidirectional fibers, they can be purchased with variable ratios of a certain number of fibers running one way and another percentage of fibers running a different way. So there's also hybrid weaves. So this is a combination of carbon or Kevlar or fiberglass, and basically this is done to obtain better durability. It can also be done for aesthetics. So if you want something that looks real high tech, you can do a carbon fiber layup with a blue or yellow or red Kevlar material in it, and it makes a very nice, pretty lamination. But typically it's done for durability. That's all I have for you for the different fibers that we use. If you have any questions, feel free to contact your instructor.